Assalamu alaikum. Hi, my Asia girls, class 7. How are you? I hope you are well, inshallah. I'm also well. Although we are going to very critical situation for coronavirus disease, but I think life is going on. We cannot stop it. We are staying at home, and I think it would be better to study at home. And I don't know. Have you remembered that in the last class we have started a new chapter? The chapter name is Heat and Temperature. It is chapter 9 and its page number is 90. Now I am discussing about with you in this chapter. And to study, I think you have already completed this chapter. But I'm just discussing some of the important topics with you. First of all, to read this chapter, you have to know, or you have to clear your concept. It is what is heat and what is temperature. It's very important. Okay, what is it? Heat is an first of all, heat is an energy, light energy, sound energy. Okay. Electrical energy, it is one type of energy. And what type of energy? That's the question. Whenever we touch anything, we feel it either hot or we feel it either cold. This hot or cold sensation, this is called heat. And how much heat or how much cold we feel it, how much hot or how much cold we feel it, this measurement is called temperature. Okay, so heat is a sensation, or heat is our feelings, hot or cold, either hot or cold. And temperature, it is the measurement. When we go to any measurement about heat, this measurement is called temperature. Okay, look at there are 3 glasses. One is normal water, another one is also normal water, and look at these glasses, it contains hot water. Okay, so, and look at this is ice cube. Okay, this one ice cube, and when I feel it, it is too much cold. So this is pure normal water, this is normal water, and this is hot water, and this is ice cube. And this ice cube, tell me, it is hot or cold? Obviously it is cold. So if it is cold, it is the cause of what? Heat. Yes, it is actually cause of heat. This ice releases its heat. For that reason it becomes cold. And when I just throw this ice cube into this glass, so this glass, and it releases its heat. It look at this is ice cube. I throw it, and gradually this object, water, it has original temperature, and whenever it touches this ice, it loses its temperature and it becomes cold. And to feel it how much cold, we have to wait for 2 minutes. Again, this is hot water, but this is my normal water. And when I pour this hot water into these glasses, we have to wait for just 1 minute. No, I've just pour, and we have to wait for 2 minutes. And now I feel it. It becomes hot. That means here water, it has an original temperature, and when I pour this hot water, it absorbs its heat. And here object is our water, and also this glass, because I don't touch my water, I touch my glasses, and I just feel it becomes hot. So here this object, water, and also my glass, they absorb heat. For that reason I feel it, it becomes hot. And if I feel it, look at my ice melts and it becomes small. Okay, now when I touch it, I feel it. Look at this bubbles, look at this vapor. I don't understand. You look at this here. When I touch it, it becomes cold. So in this experiment, simple experiment, we can say that whenever an object releases its heat, it becomes cold, and when an object absorbs heat, it becomes hot. So anything, if we call it, it is hot or it is cold, that is the result of either absorption or realization. If they absorb it, we call it, it becomes hot, and if it releases its hot heat or loses its heat, then we call it becomes cold. So anything, heat, hot or cold, is the cause of heat, and the thermal condition of anything or the measurement of how much heat, hot or how much cold it is, if I want to measure it, it is called temperature. Do you understand it? And look at, this is my bedroom and I am here with you. Okay, I think in this experiment you easily understand what is heat, what is temperature, and what is their difference between them, and when we call when an object becomes hot and when an object becomes cold. And it is also, you have to also know that heat is always flows from higher temperature to lower temperature. It is another characteristics of heat. It always transfers heat from higher temperature to lower temperature. For example, when I pour our hot water, this our glass, it contains normal water, it absorbs heat. So our poured water, it contains hot water, and it heat originally flows from higher temperature to lower temperature, and now it becomes hot. Okay, girls, do you know that your Miss Egypt Miss, I miss you very much. I don't know either you miss me or not, but I miss you very much. I remember your cute faces. Whatever, anyhow, now start our lesson again. And if I want to tell you that to measure your body temperature, how can you measure it? I think you obviously said that it would be thermometer. Exactly. For temperature measurement, we use thermometer. Okay, and I think everyone has thermometer at your home, and like this, I have also thermometer. Do you know use of thermometer? Thermometer we just not only use to measure our body temperature. Thermometer or meteorologists, they also use thermometer. They use thermometer to measure the temperature of air. For example, we said that it's what is the temperature of what is our room temperature? Either it is 35 degrees Celsius, or we call it 30 degrees Celsius or 25 degrees Celsius. It is a measurement. And do you know meteorologists? Who are meteorologists? Meteorologists are those who forecast weather to us. They are called meteorologists. Okay, now if you discuss about thermometer, it is actually measurement of temperature. We use thermometer. We use liquid. We know matters are three types: solid, liquid, and gaseous. Liquids heat expansion rates too fast, and we always want to get more quick result. For that cause, measurement of temperature, scientists use liquid, and in that case, mercury and mercury used widely to measure temperature. And now look, this is a mercury thermometer. Okay, we use this mercury thermometer because mercury is a liquid, and when it applies heat, heat expansion rate is so fast. For that reason we use mercury. And in my hand, this is a mercury thermometer. I collect it from my home. If you look at this thermometer, okay, this is, look at, this is thick walled glass tube. Okay, look at, you get the sound. Okay, and this is thin walled bulb. And if you notice it, when they manufacture this thermometer, this is a closed, but when they manufacture time, it is open, and they kept it open. Okay, this portion is kept it open, and they put a very little amount of dry solid mercury in it, and then they close this end. And mercury, their position is just here. Okay, and this thin bulb, we look at this bulb, and when I touch it, just I feel it's closed, but it has a numerous number of bore. Okay, bore. This bore is extremely so narrow. For that reason, we cannot see it in our with our naked eyes. Okay, I cannot notice any bore. I think you cannot notice it. Yeah, at your home, if you have a thermometer, you can also touch this. You do not find any bore, but it contains bore. It is extremely narrow. When I just insert it into my body, this bulb gets heat. And when this bulb gets a slight amount of heat, it gets slight amount of heat, it reaches quickly to our mercury, and mercury expands in the response of heat is so fast. For that reason, there is a scale, and in this scale we can mark it, we can understand it, how much temperature in our body. Okay, if you look at, I measure temperature, and it is 100. Look at this, a black. Look at this is a black. I don't understand, either you look it or not. It is, look at, this is a black. Look at this is a black. This black is a reason for our mercury. Okay, in ancient time, people also used alcohol, but in this present time we do not use alcohol, because alcohol heat expansion rate is lower than our mercury. For that reason, we use mercury. If you use mercury, we get more faster result, and it has and it's also its heat expansion rate is faster. So if we understand the structure of thermometer, we can say that it's a thick wall glass tube, and at the it has at one end it has a thin walled bulb. This bulb contains bore, but it is extremely narrow, so that we cannot see in our naked eyes. And at the manufacture time, this another portion, it is kept open, and in that portion dry mercury inserted, and then this portion is closed, and then other rest of the tube, it becomes hollow. There is no mercury in this portion, and there is a marking. For that reason, we can understand how much mercury heat expansion rate, and how much mercury expanded in response of heat. We can say that his or her body temperature is either 98.4 degree Fahrenheit or 9900. Okay, now can you tell me, when we call any of our friends, I have a fever. Okay, when you call it, I have a fever, it's a question. Do you know what is our normal body temperature? Our normal body temperature is 98.4 degree Fahrenheit. And now you can tell me or ask me a question, Miss, what is Fahrenheit or what is Fahrenheit? We do not know Fahrenheit. Okay, Fahrenheit is measurement scale. Okay, I'll discuss you later. And then so if your friend tell you that listen, my body temperature, when I measure my body temperature in a thermometer, I measure it, it is 99 degree Fahrenheit or 100 degree Fahrenheit. We become so much concerned and we go to doctor that he or she might be a fever. No, fever, when we call it or when we consider it fever, okay, our normal, first of all I could say it, our normal body temperature is 98.4 degree Fahrenheit. So if our body temperature rises 99 degrees Celsius, 99 degree Fahrenheit or 100 degree Fahrenheit, we cannot call it he or she has a fever. It depends when his or her body temperature rises up to 100 degrees Celsius, then we call it he or she may be fever. So if you find it your body temperature rises, first you have to know, you have to measure it is in your thermometer. If you find it temperature is 99 or 100, you do not get so much panic or it doesn't need to go to doctor. You just consider it your temperature is, body temperature is rising. Okay, and when it is more than 100 degrees Celsius, then we call it he or she might be attacked by fever, or he or she may have fever. Okay, so concept is clear. Now we go to the measurement scale. When we want to measure anything, it is temperature or it is length, we have first step is to fix a unit of a thing as a standard measurement. And for the measurement of temperature, we use two fixed points. One is boiling point, another one is melting point. What is called melting point? The normal temperature at which an ice becomes melt under normal pressure, it is called melting point. And in the same way, at the normal temperature, when pure water boils and starting to evaporate, and that is called our boiling point. And this is our, and between this boiling point and melting point, we divide this. Okay, we divide this in the fixed portion. Okay, the interval between boiling point and melting point, we divide it at this fixed amount. Okay, for example, nowadays there are two scales that is widely used. One is Celsius scale, another one is Fahrenheit. For example, you have already known that whenever we call the room temperature is 25, when it is called, what we are called 25 degrees Celsius, we do not say 25 degree Fahrenheit. Okay, we call it 25 degrees Celsius or 30 degrees Celsius. When we go to for measurement of body temperature, we call it is 100 degree. You always follow that 100 degree is not a Celsius. 100 degree is Fahrenheit. 101, 102, 103, 104. It is for Fahrenheit, and Celsius is another. And the scientist Celsius first introduced us this type of scale. For that reason, this scale is called Celsius scale. In this Celsius scale, melting point is considered as 0 degree, and melting point is boiling point is considered as 100 degree. So 0 and 100, and 0 and 100 between this interval, and they divided into he divided into 100 parts. So 0 and 100, the interval is divided into 100. And in case of Fahrenheit scale, scientist Fahrenheit introduced this scale. So in the same way, this scale is called as Fahrenheit scale. Fahrenheit considered that melting point is 32 degree and boiling point is 212 degree. So the interval between 212 and 32 is 180. So between melting point and boiling point, he divides all of these into equal 180 divisions. Okay, so Celsius scale and Fahrenheit scale in that case is the same way. Anything we can regard as 0 to 100, anything we can regard as 32 to 212, but there is a relation between Celsius scale and Fahrenheit scale. What is the relation? Relation is you also find this relation in your book. It's a simple equation. This equation is C by 5 is equal to F minus 32 by 9, and in this equation we can solve so many math. For example, in your math in your question ask you the Shami, a girl, her body temperature is 40 degrees Celsius, convert it as Fahrenheit scale. So you can, from this equation you convert it Fahrenheit scale. Or if your question tell you another girl, her body temperature is 35 by 102 degree Fahrenheit, convert it in Celsius scale. So you can convert it easily from this equation. C by 5 is equal to F minus 32 by 9. And I have also do this math. If you notice it, I do this math here. It's very simple. You can, if you just practice at your home, I think you can do this math, and it is also important for you because in your upcoming exam, we always prefer to give you such type of math. Either we tell to convert it Fahrenheit or convert it Celsius scale, vice versa. Okay, so at the end of this I think this is the end of this class, and in the next class we have to discuss about the heat expansion of a matter due to heat. In the next class we have to discuss about it, and in this class you have to prepare or learn something. Number one, what is heat? Number two, what is temperature? Number three, what is the difference between heat and temperature? And why mercury is used in thermometer? Its answer would be, you can answer would be such way: its mercury expansion rate due to heat is more higher than any other metals like alcohol. We need to get more quicker result. It shows more quick result than any other metals or other matters. For that reason, mercury is widely used in thermometer. And you have to also learn structure of mercury thermometer. When you describe the structure of mercury thermometer, you should give its figure in your answer script. Okay, and this is our end of the classes, and I think my discussion would help you to prepare this chapter. And in the next class, but the last portion, expansion of heat due to matter, I have to discuss it. And take care and stay at home, and I might tell you study more and more. Okay, till bye, goodbye, see you again.